So in this video, we're going to look at differentiating composite functions using something called the chain rule. So the chain rule is used for differentiating composite functions, and in functional notation, if f of x equals f of g of x, where g of x is the inside function and f of x is the outside function, then the derivative of the composite function equals the derivative of the outside function multiplied by the derivative of the inside function. So in other words, f dash g of x multiplied by g dash x. In Leibniz notation, if y equals f of x, where f of x is a composite function, then dy by dx equals dy by du multiplied by du by dx, where y is a function of u and u is a function of x. And this is easier to demonstrate by looking at some examples. So in our first example, we want to differentiate, using the chain rule, the composite function of 3x plus 7 all to the power of 4. So our outside function is 3x plus 7 to the power of 4, and our inside function is 3x plus 7. So we want to differentiate the outside function, and then we want to multiply that by the derivative of the inside function. So to differentiate the bracket, we're leaving the 3x plus 7 inside the bracket, and we're bringing down the 4 as our multiplier. So it's going to be 4 upon 3x plus 7 all to the power of 3. And then we're going to multiply that by the derivative of 3x plus 7, which is 3. And then we need to simplify our expression. So the derivative of our composite function is 12 multiplied by 3x plus 7 to the power of 3. Now in the next example, we want to find the derivative of s with respect to t. So the first thing we're going to have to do for our s equals the square root of 2 minus 3t is remember that everything underneath the square root sign is in a bracket. So to differentiate it, we need to change the root into a fractional power. So it's 2 minus 3t to the power of a half. So then we need to apply our differentiation. The inside function here is 2 minus 3t. So in Leibniz notation, the derivative of s with respect to t equals a half multiplied by 2 minus 3t to the power of negative a half. And then we're multiplying that by the derivative of 2 minus 3t, which is negative 3. Now we need to do some rearranging and simplifying. And so we're going to end up with negative 3, and that's all over 2 multiplied by 2 minus 3t to the power of a half, making it into a positive index. And then we're going to change that fractional index back into a root. So our final answer is going to be negative 3 all over 2 multiplied by the square root of 2 minus 3t. In our final example, we want to find the derivative of the function of x. Our function of x this time is 1 over x cubed plus 3x. Remembering the divide by line means that there's brackets around the numerator and the denominator, and our bracket will be to the power of 1. So to write it in a way that we can differentiate it, we're going to make that a negative 1 power, and so our function x equals x cubed plus 3x all to the power of negative 1. And our inside function this time is x cubed plus 3x. So the derivative of our function with respect to x is negative x cubed plus 3x in a bracket to the power of negative 2, and we're multiplying it by 3x squared plus 3, which is the derivative of our inside function. And again, we need to do some rearranging and creating some positive powers. So we're going to get negative 3x squared plus 3 all over x cubed plus 3x all squared.